Hello everyone. In this video we're going to talk about tuples, or if you pronounce it as tuples, or what have you, it doesn't really matter, both are accepted. I will be pronouncing it as tuples. Regardless, tuples, they are a data type, just like an int or a string, a float, and so on, any of these things that we've been using up to this point. However, they are a very specific type of data type, in the sense that this data type, a tuple, can hold multiple values. It can hold multiple types within a single variable. Now, it's not at all like an array or any other collection type. It is a structured data type. What this means is that a tuple, generally speaking, when we use tuples, we use it to hold multiple values of different data types to describe, generally speaking, an object at large, some single thing. Whereas collections like dictionaries or arrays, these are sequences. That means that it contains multiple values, generally of the same data type, and also generally with no correlation with one another. So arrays and tuples are very different from one another. The biggest difference that I would like to point out is that arrays can be added to and removed from. They also contain lots of built-in functionality, some really great things out there in the Swift standard library. Tuples, on the other hand, they generally do have multiple values, yes, but once it has been declared with values, let's say 3 values, it can only ever have that many values, and of those declared data types. So where my tuple could have a bool, a string, and an int, well, it's only ever going to have those 3. It could never add on to that. It is a structure of those 3 forever. Alright, so now that we got that out of the way, let's just start seeing how we can put these tuples into practice. So I'll go ahead and create a tuple of information that describes Jane at large. So she'll be 25 years old, has blue eyes, and is not male. So I'll start off by creating this variable Jane, and assign it equal to, anytime that we would like to create a tuple of information, we do so by using the parentheses, and any values that we place in here, firstly we have to comma separate them, but any values in here will be a part of the tuple, will describe Jane in this instance. So I'll say that she is 25 years old, has blue eyes, and false, she is not male. And over here in the values pane, we can see that the very first value here is the value of 25, the second being blue, and the third being false. And prefacing it, we see in these lighter gray color, .0, .1, and .2. So we'll kind of get into what that exactly means right now. So let's go ahead and print out her information. To specify each of these values, the age that we said, and the eye color, as well as the not being male, we have to use dot syntax and then say which value position it resides. So that's why we saw the .0, .1, and .2 here. That describes which location these values are in our tuple. So I'll go ahead and print this out to the console. I'll just use some string interpolation here. So I'll print out Jane is, put my placeholder here, I'll say Jane.0 years old, has Jane.1 eyes, and is male, colon, and I'll use string interpolation one final time, say Jane.2 to put that true or false there for this is male or not. Additionally, let me just go ahead and show you the code sense. When we type out Jane, notice the data type in code sense says we have a tuple containing these 3 values. We have an integer value, a string value, and a bool value. Whenever I fully type out Jane and I use dot syntax to grab each of these values, we see that 0, 1, and 2 are those properties of Jane, and they are an int, a string, and a bool respectively. So that's what I'm doing within my print statement. Now there is kind of one downside to this. The downside is, just looking at it, how do we really know that, well, .0 is supposed to represent an age, .1 is supposed to represent an eye color, and .2 is supposed to represent whether or not she is male or female? Well, it's not easy, right? It's not easy for us developers to glance at it and tell what these values are supposed to be used for. So that's where external names come into play for these tuples. So we can be a bit more descriptive than .0 or .1, .2, and so on. We can specify, well, 25 is supposed to be an age, blue is supposed to be an eye color, and false is supposed to be the is male value or not. So to represent this, I'll go ahead and create another variable, and I'll create better Jane. This is the better version to do things when we're working with tuples. So I'll say age is 25. This is how we write it out. So I would say this is the name of this value, age, and has a value of 25. Let's go ahead and say the eye color has a value of blue. And then finally, the is male value has a value of false. So with external names, we don't need to specify each of these values with a number. We can just use the names. In fact, if I say better Jane, firstly the code sense is going to tell me, well, age is an int, eye color is a string, is male is a bool. We get more information with the type annotation here. And then if I say, well, better Jane dot, I no longer have the 0, 1, and 2. I now have an age, an eye color, and is male. It's a bit more descriptive. So let me print this out to the console. I'll say print. Jane is, and I'll use better Jane's info. So better Jane dot age years old has better Jane dot eye color, eyes, and is male. We'll see a better Jane dot is male. Now, while this is a bit more wordy, a bit more typing, it's better. It is better for clarity. It's better for us, the developer, to notice at a glance what the values should be. Now notice we can also explicitly declare these external names on each of the tuple components. However, if you do so, the external names must be on the type annotation, okay, in order for it to work properly. So I'll write it incorrectly first, and then I'll write it the correct way, but know that the type annotation is that explicit declaration part, alright, so that colon, and then whatever the data type of that variable is, that is known as the type annotation. So I'll start off by saying, let John. And John equals, well actually let me explicitly declare him to have an int, a string, and a bool. And then assign him equal to something very similar to this. I'll just modify the values a bit. So equals this, I'll modify this, John is actually 30, he's got hazel eyes, and his male is true. Now while this is compiling, while this is working fine, if I wanted to print out or work with John's information, if I say John dot, I'm still only working with 0, 1, and 2, even though these labels exist for each of the components inside of my tuple that describe John. They're not used. They're not used because John was explicitly declared without those labels. Alright, so John.age doesn't work. Let's comment this out. Let's write it the correct way. So this time I'll say, well, let John. We'll explicitly declare him. This time we will include these labels for our components. I'll say age is an integer. Eye color is a string. And is male is a Boolean value. And then I can assign this equal to the tuple containing the values 30, hazel, and true. If you would like, you can still put the labels in the literal part right here on the right-hand side of the equal sign, but since our explicit declaration, our type annotation right here, does include these labels, it is not necessary. In fact, let me go ahead and print out John's information now. So John is John.age, years old, has John.eye color, eyes, and is male. John.is male. And let's just take a look at the console, what's happening instead of just over here on the values pane. It does say that Jane is 25 years old, has blue eyes, and is male. Even though that our first two prints say the same thing, the second one is more readable in code for us. And then finally we do have John being 30 years old, having hazel eyes, and is male. So, the next thing that we can do, it's a really nifty trick, it's fantastic, is we can actually decompose tuples into independent variables or constants. So while we do have a tuple, this one singular variable named John containing these three values, we can break up these three values into separate independent variables or constants. The act of doing so is known as decomposition or decomposing tuples, so let's see this in action. I would like to create these three variables. Now the way that we write it is we go to declare some variable, and we declare it as a tuple with whatever the three names that you would like these independent variables to be. So I'm going to name mine my age, my eye color, and my is male. So these three are uniquely named. And what we do is we'll just assign this to the tuple John. Now, when the code sees this, it says that we are creating three variables with these names inside of a tuple. When we assign that to some tuple variable like so, like John, who contains those three, what it does is it actually breaks it apart and then takes his age, which is the first value, places that into the very first variable name. These could be named whatever you would like. Takes the second one, eye color, places that into the second variable, and then takes the third one, places that into the third of this variable tuple. So us doing this, we have just decomposed the tuple. We can use these as separate variables. I could print out the console now that John is my age, years old, has my eye color, eyes, and is male. My is male. Notice that I don't have to ask John for his age or his eye color or his is male variables or components inside of this tuple. Instead, because we have decomposed it, I can use these as I wish, independently from one another. And it does print out to the console the same information as before. John is 30 years old, has hazel eyes, and is male. So, as we can see, tuples are used to describe an object. We generally use the multiple components to describe something at large, like we use an age, an eye color, and the is male values to describe some person, John or Jane. And like was said before, tuples are a data type. We said that John is a data type, is a tuple of these three components. And because tuples are data types, just like ints or strings and doubles, we can also use tuples as parameters or even returns from functions. So keep that in mind. Lastly, tuples can be very useful when we loop through collections of data. So I've got an array right here. It's got some colors in it, red through purple. And we can use the enumerate method on our array, on our collection here, within a for-in loop to get back both the elements index and value at the same time. So let's go ahead and see how that works exactly. I could say for, and I'll just say tuple in colors.enumerate. And looking at just the description of what enumerate does, it says, well, it returns a sequence type containing pairs. Notice the parentheses and the comma separated n and x values, where n's are consecutive ints starting at 0, so this would be our index, and x's are the elements of the base, so this would be the actual values contained within our collection. But because this is comma separated within these parentheses, we see that it is actually a tuple. That's what we get back when we call enumerate. So for tuple in colors.enumerate, I can go ahead within my for-in loop, just print out to the console the color at index tuple dot, let's see, pretty sure it's index was tuple.element. And the way that you can be certain, I got it right, but the way that you can be certain is if you type out tuple and you use .syntax outside of string interpolation, CodeSense will pop up and tell you what the two values of this tuple is. So they were actually named element and index. So that's what is being returned. If I take a look at the console output now, it will tell me for that collection of colors that I had, the color at index 0 was red, 1 was green, all the way down to 5 being purple, which is great. But we can also take what we just saw up here, the decomposition of tuples, and then apply that to the enumerate method for for-in loops. So I could do something like so. I could say for index and color in colors.enumerate. So I'm decomposing the tuple that is returned, where the index was first and then the value was second. I named it color. It could be any name that you want. It doesn't matter. And then I can just print out to the console pretty much the same thing. I'll say the color at index, use them as two separate variables, was color. Also loops through 6 times, and we see, now let me actually place a print line in between these. Alright. There we are. We can see now the color at index 0 is red, 1 was green, 2 was blue, all the way down to 5 being purple. We have this written out twice. So that's what we just saw. We just saw that the enumerate returns a tuple. We use it as a tuple first, and then we decompose the tuple second into these 2 separate variables to use them. So tuples are a fantastic addition to the iOS SDK. If you'd like to go ahead, check out this link here. This link will bring you to the documentation on tuples. You should have read about it already, but it's nice to have that link there anyway. Well, that does it for this video. Thank you for watching.